Hello friends, welcome back. Today we are going to start with geometric progression. In the earlier video you have seen arithmetic progression, which depends upon the concept of common differences. In this topic you will see the concept is based on common ratio. Let's take some example to begin. Say we consider sequence of numbers 2, 4, 8, 16, 32, 64 and say 128. It can keep going. Let us say we restrict till 128. By observation we are realizing that the common ratio is equal, that is 4 upon 2 becomes equal to 8 upon 4 is equal to so on 16 upon 8 is all equal to 2. So in any sequence of numbers, if the common ratio of the preceding term to the earlier term is remaining constant, then such a sequence is called geometric progression. Let us explore this. Let us consider the first term a1 as equal to 2. Let us say we can even write it as a. So let a1 be denoted as a. a2 in this question is 4. This 4 can be written as 2 into 2, where 2 is a and another 2 can be thought of as common ratio. Let us denote the common ratio with r. So r can be replaced in place of this 2, so it becomes equal to ar. Let us take third term a3. From the sequence it is 8. This 8 can be written by us as 2 into 2 square. The 2 here can be thought of as a and r is 2 raised to 2, so it becomes ar square. Let us take the next term of the sequence a4 and we get that as 16. 16 can be written as 2 into 2 cube is equal to a into r raised to 3, that is a r raised to 3. From here you are realizing that the suffix 4 here is 1 larger than the degree of r. A has degree 1 only. Therefore, in general, we can write nth term of a GP as a into r raised to n minus 1. You can reduce the degree of r by 1 to whatever the suffix is here. This can be also written as Tn is equal to a into r raised to n minus 1. We can even learn this as last term is equal to a into r raised to n minus 1. From here we can interpret some simple examples, like if you come across to get a8, then the result can be thought of as ar raised to 8 minus 1, which is a into r raised to 7. So this way, while problems arise, like when we will solve the questions further, we will be using these results directly. Let us take an example to get some better idea about what we are trying to say. Let's say we take a question. Like this. Okay. So we have a question coming up. The question is, which term of the list of numbers is 512 upon 729? Now here they have not said that the given sequence of numbers is in AP or in GP. Clearly, common differences are not equal, but the common ratio looks visibly same. Let's verify it. So we can write here the first term is 18 and the common ratio, let's check it, is minus 12 upon 18. Let us also verify, is it equal to 8 upon minus 12? Yes, it is equal to minus 2 upon 3. You can verify it. The last term, they are saying which term of the list of numbers. So in future you are getting this particular term. So they have said an value as 512 upon 729. And what's our work? Our work is to get n, because you want to know which term, which means you have to find out n. Let us get an formula. An formula is a into r raised to n minus 1. Therefore 512 upon 729 is equal to A is 18, your first term, into R is minus 2 upon 3 raised to n minus 1. Our whole objective purpose is to get n. We can divide by 2, or okay, let's not do that. Let's take 18 here first. Let's write step by step. So it will become 512 upon 729 into the 1 upon 18 is equal to minus 2 upon 3 raised to n minus 1. Let's cancel out. 2 9s are 2, 256 are. Therefore, we get 256, which is a very popular number with us. It is 2 raised to 8 upon 729. We all know is 3 raised to 6, while 9 is 3 square. Now suddenly you must be thinking, why are numbers written in indices form? Why is 2 written? Because here in the bracket we have 2 and 3. That's why we are trying to express the left hand side in terms of 2 and 3. So this 6 and 2 will become 8, which can be written as 2 upon 3 raised to 8 is equal to minus 2 upon 3 raised to n minus 1. But because the degree is even, you can think about minus 2 upon 3 raised to 8, which will mean the earlier step only, is equal to minus 2 upon 3 raised to n minus 1. In 9th standard, you have learned a topic called indices, one of the easy and favorite for many. So whenever bases are same, you can equate the powers. So 8 becomes equal to n minus 1. Therefore, n is equal to 9. That is what they have asked. Which term? So which term of this sequence of numbers which would have given you this answer? It would have been 9th term. Let us take the next point. Let us try recollecting how to find nth term from ending. Nth term from ending. What were we doing while doing arithmetic progression? Yes, we were starting with the last term as the first term. So here nth term from ending, let us say we denote it as Tn. From ending, so your last term will act as first term, but the common ratio is going to become not r but 1 upon r, as your series of numbers are going to be observed from the opposite order. We will take an example for you. Say you have a simple example 2, 4, 8, 16 and 32. Now here clearly the common ratio is of 2, but if you are observing from here, then your sequence is 32, 16, 8, 4 and 2. Therefore your common ratio will become 16 upon 32. Your common ratio will become therefore 1 upon 2. So we don't want 2. If you are reversing the order, the new ratio will become reciprocal of 2. That's why we are writing 1 upon r here. Now let us take an example. We would advise you to keep this to your memory. Recollect for an arithmetic progression for an AP. I'm just trying to recollect for you. We have done this in earlier video. Tn is equal to, we have learned L minus n minus 1 into d, if you can recollect that. Let us take an example now for geometric progression, as today we want to complete this topic. Let's take a question. Let's take a question of this type. Find the 7th term from the end of the list of numbers. Again, it is not said whether the list of numbers are in arithmetic progression or geometric progression. By observation, you have realized that this is a geometric progression. A is 3, your common ratio is minus 6 upon 3 is remaining equal to 12 upon minus 6 is equal to further numbers, if you would have tried, is equal to minus 2. Let us write simply r as equal to minus 2. R is equal to minus 2. We want to get the 7th term from the end of the list. Now this term is going to act as last term. So we can write, since Tn is equal to L into 1 upon r raised to n minus 1. Therefore Tn, or let's write 7 now, as you want the 7th term from ending. is equal to 3072 into 1 upon minus 2 raised to 7 minus 1. Let's evaluate this. This becomes equal to 3072 into 1 upon minus 2 raised to 6. 2 raised to 6 would become 64. Is it okay? Yes, you can verify it. Now let's see if we can cancel this out. 16 fours are, let's try with 16 ones are, then you have 14 remainder, right? 147. So 16 8 9s are 144 hoga, 32 is remainder, 2 remains. This will become 4 ones are and 4 fours are, and then 48, 32 is coming, so 48. So we conclude that 7th term from ending is 48. Let us take a board question. Let us take a board question on the same type. Say we take a 2018 question. The question goes as, the 4th term of a GP is 16. So T4 is 16 and the 7th term is 128. T7 equal to 128. Find the first term. So you have to get A and common ratio of the series. Let's try solving this. This looks manageable. We can write, since this time we have chosen the denotation as Tn, since Tn is equal to AR raised to n minus 1 for a GP, because it's already said it's a geometric progression. Therefore T4 will become A into R raised to 3, but T4 being 16, we can write this as 16 is equal to A R raised to 3. Let us number this as equation 1, and we have T7. T7 is equal to AR raised to 6. Therefore 128 is equal to AR raised to 6, as T7 is given to you as 128. We have got two unknowns and two equations. Subtraction will not help, division can help you. Let us therefore divide 1 and 2. So we can write dividing 1 and 2. We will get 16 upon 128 is equal to AR raised to 3 upon AR raised to 6. We could have done the division vice versa also. Higher power of R would have remained up. That's okay. 16 ones are 16 eights are. A is non-zero. Otherwise 0 upon 0 is non-cancellable. We will assume the first term is never 0. And this becomes 1 upon 8 is equal to 1 upon R raised to 3. As 3 gets subtracted from 6, 6 minus 3 is 3. R cube is equal to 8. Therefore taking cube roots, we get R as equal to 2. That is what they have asked. Get us the common ratio. They have also asked us to get the first term. Recollect. We have got from 1. Since we have got from 1, 16 is equal to AR cube. 16 is equal to AR cube. This we have got from 1. Therefore 16 is equal to 2 into R cube. Let's solve this. 16 upon 2 will become 8 is equal to R cube. Taking cube, R was 2 for us. So we get here A into 2 cube, that is we get here 16 is equal to, 8A. Therefore A is equal to 2. That is what was asked. Find the first term and the common ratio. Let's see the question one more time. The question is, find the first term. The first term is 2 for you and common ratio is also 2. They could have asked for one more mark, hence get the 10th term. Then using A and R, we could have got the next term, the 10th term, if they would have asked. So this was the question of 2018. I think that was manageable type. Most of you must be thinking Same question we should also get in our exam. Don't worry, you will get simple questions. Let's take one more. Let's take one more, a recent one, 2020 question. The question is, if the fourth, sixth and last term of a geometric progression, already said it's a geometric progression, are 10, 40 and 640 respectively. So let us express this data. We have got T4 as equal to 10. We have got T6 as equal to 40 and Tn is equal to 640. This is given, nth term, that is the last term. If the common ratio is positive, तो शायद ऐसा आता होगा कि R के दो आंसर आ रहे हैं प्लस और माइनस, तो they are therefore saying choose positive only. Find first term A, find common ratio R. So you have to get A, you have to get R, and number of terms of the series. So you have to get N also. Let's begin. We can write for a GP, Tn is equal to A into R raised to N minus 1. Therefore T4 is equal to AR raised to 3. Just similar to the older problem. We are getting therefore how much is T4? 10. 10 is equal to AR cube, equation 1. And we can now write T6 is equal to AR raised to 5. Therefore 40 is equal to AR raised to 5. Let's number this as equation 2. Let us divide both the equations as we did before. This time let us say we divide 2 by 1. Let's divide 2 by 1. So we get 40 upon 10 is equal to AR raised to 5 upon AR cube. Therefore 4 is equal to, you can verify, A getting cancelled. This will remain as R square 5 minus 3. Do not forget to take both roots. Therefore answer is plus or minus 2. Therefore R is equal to 2 since R is positive. That is what they have said, common ratio is positive, and this also happens to be one of our answer. Let us now again consider from 1, what was the step? 10 is equal to AR raised to 3. Therefore 10 is equal to A into 2 cube, which is 8. Therefore A is equal to 10 upon 8, which is equal to 5 upon 4. So that gives you the first term. Therefore A is equal to 5 upon 4. That's making a box over it. Now let's explore the last data. They have said nth term is 640. So since Tn is equal to 640, therefore AR raised to N minus 1 can be written instead of Tn is equal to 640. But A is 5 upon 4, R is positive 2 raised to N minus 1 equal to 640. Let's evaluate. This looks manageable. 2 raised to N minus 1 is equal to 640 into 4 upon 5. You can reduce this. 5 ones are 5 ones and then 14 may 2 times, 40 may 8 times. This gives you therefore 2 raised to N minus 1 is equal to 2 raised to 6 into 2 raised to 2. As left hand side you have exponential form, that is indices form. That's why we have picked up 2 in the right hand side. So 6 plus 2 will become 8. Don't multiply the powers, add them. Therefore N minus 1 equal to 8. Therefore N is equal to 9. So they have asked also find number of terms. We have got all the 3 answers. Let's see the question one more time and check it whether we have fully solved it or not. They have asked us find the first term, common ratio and number of terms. R was to be taken positive, so that we already discussed. So A 5 by 4, R is 2 and N we got as how much? 9, right? So these level of problems are seen in board exams. Let us continue. with choice or selection of three numbers in AP. Let us write a heading, selection of numbers in GP. So if you have to choose three numbers in GP, then we would advise you to choose them as A upon R, A and AR. If you are required to choose four numbers in GP, you can choose them as A upon R cube, A upon R, AR and AR cube. And five numbers can be selected as A upon R square, A upon R, A, AR, AR square. The advantage is that if they give you a data like product of three numbers is say 8, then product of three numbers is 8 will lead to multiplication of these three numbers and equating to 8. That will lead to cancellation of R and you can get A value after solving. Same applies with other numbers also. Here, just for observation part, remember the common ratio here was R only, but in this case the common ratio is R square. You can verify it by doing A upon R cube. A will get cut and R square will remain when you cancel R with R cube. So common ratio in the second, that is when you are choosing four numbers, as R square, while in the first case it's easy to understand, A upon R. A will get cancelled out, R will go in numerator and become R, hence R. Similarly with five numbers, the common ratio remains as R only. Let us take a question to get this concept more nicely. Let's take a question like this. Say the question is, the product of first three terms of a GP is 1000 and product is mentioned. Now we can therefore from the earlier experience take the three numbers as A upon R, A and AR, and the product of them is said to be equal to 1000. This leads to cancellation of R and you get A cube is equal to 1000. Therefore A is equal to 10 on taking cube root. Further they are saying if 6 is added to the second term was A here, and further it is said and 7 is added to its third term, then the terms become in AP. Find the GP. So let's first add. Now first let's keep the first term as it is, A upon R, comma, in the second term you are going to add 6, so it will become A plus 6, and in the third term you are adding 7, so AR plus 7, and now this is an AP. The funda of AP is that common differences are equal. This can lead you to writing of, therefore, can we put A as 10 first? Let us do that. So 10 upon R, 10 plus 6 and 10R plus 7 is still in AP. Let us write this as 16. So 10 upon R, 16 and 10R plus 7 is still in AP. For a AP, the common differences are equal. Therefore, 16 minus 10 upon R is equal to 10R plus 7 minus 16. Therefore, 16 minus 10 upon R is equal to 10R minus 7 minus 16 is minus 9. Let's multiply throughout by R, that is the LCM. So it is 16R minus 10 is equal to 10R square minus 9R. Let's write this quadratic in descending order of R. 10R square minus 25R, 16R gets subtracted from minus 9R, plus 10 is equal to 0. We can divide by 5 to obtain 2R square minus 5R plus 2 is equal to 0. Let us factorize this quadratic by splitting the middle term. Product is 4 and middle term is minus 5. So factors are minus 4 and minus 1. So you get 2R square minus 4R minus R plus 2 is equal to 0. 2R, R minus 2 minus 1 R minus 2 is equal to 0. We get r minus 2, 2r minus 1 equal to 0. So r is 2 or r is half. There is nothing said that r can't be a fraction. So we have to accept both values. Now we have got a as well as r. Let us write three numbers. So let's write when a is equal to 10 and r is equal to 2. In this case, we have a upon r, a and ar becoming 10 upon 2 comma 10 comma 10 into 2, which becomes 5, 10 and 20, right? 5, 10, 20. Let us choose the other case. When a is equal to 10 and r is equal to half, we will get a upon r, ar becoming 10 into 10 upon 1 upon 2 comma 10 comma 10 into 1 upon 2, which will become for us exactly reverse of what we have got before, right? We'll get exactly reverse of what we have got before, and that will be 20, 10 and 5. Let's look at the question and verify if there was anything else that we have missed out. Let's look at the question. I just take it up. Just one second. They have said find the GP, and they are saying only about the first three terms, and they are saying find the GP. So we have found the GP. We can, if we want, because it was about the first three terms, the language was first three terms. So if you want, you can express the final answer as GP is 5, 10, 20 dot dot. So it can get extended because they are the first three terms, or your GP could have been 20, 10, 5, and then again you can put a dot dot, indicating that further terms are also present in the entire GP, right? Let us now start with problems on sum of n terms. Let us write the formula. Let us write the formula for sum of n terms. Sum of n terms in a GP. The formula is Sn, S indicates sum, is equal to A into r raised to n minus 1 upon r minus 1 when r is greater than 1, or Sn is equal to A into 1 minus r raised to n upon 1 minus r when r is less than 1. Now these are the two formulas which look different, but as if you closely monitor, observe it, it's one and the same. The numerator is just reversed, is written in reversed order in the second case. Suppose a student has a question containing r equal to 5. Then we advise him to use this formula so that the numerator and denominator will both look positive. But suppose a child, when r is equal to 5, applies this formula, then the negative value appearing in numerator and negative value will appear in denominator. Negative will cancel out, and again the result will be same as what you are getting by using this formula. So don't take a lot of stress in memorizing the form. You can learn by any one way. Let us say we always, even if r is less than 1 or greater than 1, we decide to use only one form, right? Let's take a question to solve. Let's consider a board question. The question goes as, the first and the last term of a geometrical progression are 3 and 96 respectively. Find if the common ratio is 2. So r is 2. Let's write this much data, whatever we are seeing. So we are seeing the first term a is 3. We are seeing the last term, which we write Tn as 96, and common ratio is 2. We know for any GP, Tn formula is equal to a into r raised to n minus 1. अभी तक तो सम की कोई बात ही नहीं है, तो पहले what happened? Okay, I think something happened. Let me rewrite this. So r is equal to 2, and we have been given Tn equal to 96, and because it is clearly stated that the given progression is a geometric one, we can use Tn is equal to a r raised to n minus 1. Therefore 96 is equal to 3 into r is to raised to n minus 1. We can divide by 3 is equal to 2 raised to n minus 1. This gives you 32, and 32, right? 3 ones are 3, 32s is nothing but 2 raised to 5. Now this is a very common thing appearing in almost all board problems, equating the powers when bases are same. So when you equate the powers, you will get, therefore n minus 1 is equal to 5, therefore n is equal to 6. Let's see the question. What is asked? Find n, the number of terms of the GP. So number of terms is 6. The next question is find the sum. Clearly r is equal to 2 is greater than 2. Had it been even less than 2, whatever, we have decided that we will use the formula. We will use the formula of Sn as, since Sn is equal to a into r raised to n minus 1 upon r minus 1. Therefore S6 is equal to a was 3, r was 2 given to you, n is 6 minus 1 upon 2 minus 1 is equal to 3 into 2 raised to 6 is 64 minus 1 upon 1 is 3 into 63, which gives you 189. So the question's second part, find the sum of those terms, is 189. That is what was asked. We can have a look at it again. This was your question. Find the sum of those n terms. The sum of those n terms, that is 6 terms, is 189. Right? Bas, so this is it. एक और करा लेते हैं. Last question. After this, let's stop. This topic then comes to an end. एक और कर लेते हैं. How many terms of the series, and the series is given to you, not said whether it's AP or GP, will make the sum 55 upon 72. So this is already Sn for you. You have to get how many terms, so you have to get n value. ये हमारा question है. AP देख के तो नहीं लग रहा है. Let's check for GP. So we have the solution here. The first term is 2 upon 9. Let's check for common ratio. Common ratio is minus 1 upon 3. You have to include negative sign, upon 2 upon 9. 3 ones are 3 threes are is minus 3 upon 2. Verify if it is also equal to the third term upon the second term. So minus 3 will multiply numerator. It will again become minus 3 upon 2. So all this was done to make you understand that yes, it is a GP. Therefore, given numbers are in GP, given series is in GP. Now write Sn formula, right? Since Sn is given to us as 55 upon 72, Sn formula is a into, we can write r raised to n minus 1 upon r minus 1 is equal to 55 upon 72. Here we can even write the other way around, as r was minus 3 upon 2. So if you want to keep the value positive in the denominator also, क्योंकि अब आप r minus 1 नीचे लिखोगे तब तो नेगेटिव वैल्यू जनरेट होगा. तो if you want, you can interchange and write the other formula also, 1 minus r, and numerator में 1 minus r raised to n लिख देना. Let us say we stick with 1 only. A का फॉर्म वैल्यू तो 2/9 है, इंटू आर वैल्यू इज minus 3 upon 2 raised to n minus 1, the whole upon minus 3 upon 2 minus 1 is equal to 55 upon 72. Therefore, minus 3 upon 2 raised to n minus 1 is equal to 55 upon 72 into this 9 will multiply with 55, so it will become 9 by 2 here. अगर ये ऐसे देख के कन्फ्यूजन हो रहा है तो आप इसको ऐसे ऐसे लिख सकते थे, सो दैट यू विल फील more comfortable. 2 by 9, so 9 goes here into this denominator value is minus 5 by 2, so when that gets multiplied here it will become minus 5 by 2 like this along with the minus sign. So we are not writing anything in the denominator of left hand side. Let's evaluate this. So this becomes minus 3 upon 2 raised to n is equal to 55 into 9 into 5 is minus 2475, verify कर लेना, upon 288 plus 1. This minus 1 is brought here, so it's plus 1, and the denominator values are multiplied, which makes it 288. This will become minus 2475 plus 288 the whole upon 288. Verify this subtraction. ये देख लेते एक बार subtraction कितना हो रहा है. So this is becoming minus 2187 upon 288. 9 looks at divisibility 9 का दिख रहा है. 9 2s are 38 में 9 will go 4 times, 27 में 3 times. 9 2s are 18, 108 में it will go, then 10 will remain 1 time, and then 18 में, no, I think I'll have to check again. 18 2s, and then we have how much, 9 3s are, sorry, I made some mistake, I was thinking something else. So this will become 3s and then 2, so this becomes is equal to, ये तो इजी पावर्स है आपके लिए, माइनस 3 अपॉन 2 द होल रेज टू 5. एंड ऐसे प्रॉब्लम्स हमने आज किए भी हैं, वी हैव सीन देम बिफोर, सो वी कैन राइट इट डायरेक्टली. नाउ बाय लॉ ऑफ इंडाइसिस वी कैन इक्वेट द पावर, सो एन की वैल्यू हो गई 5. सो हमें ये समझ में आ रहा है कि अगर आर की वैल्यू 1 से कम भी है और हमने ये फॉर्मूला यूज़ किया जो R1 से बड़ा वाला दिखा रहा था, तो भी you will get the same answer. So there is no need to learn 2 different formulas for SN in a GP. Right? So with this we are concluding with the topic. I hope it has helped you.